We've shown the electrons here moving very fast, but this isn't quite right. The electrons actually make very slow progress along the wire, much slower than a snail. Imagine each electron is like a fly in a stationary railway carriage. The flies buzz around really quickly, but don't go anywhere. This is what electrons do when there's no current. They just buzz around randomly incredibly fast, about 1% of the speed of light, or 3,000 kilometers per second. And this is called their thermal speed. When the circuit is connected, this is like the locomotive starting to pull the train. Each carriage starts moving almost immediately as the couplings take up the slack. In an electric circuit, this is the speed at which the electrons find out that the circuit's connected. It's called the signal speed, and it's even quicker than the thermal speed, about 90% of the speed of light. Even though the carriages started moving at almost exactly the same time, they're just trundling very slowly along the track. Each fly is still buzzing around very quickly, but it's now moving very slowly with the carriage. The flies can't move along the line any quicker than the carriages are going. This is called the drift speed of the electrons. It's the speed that electrons actually make progress along the wire. This drift speed is the one that we're interested in when we talk about electric current, and it's very small, typically a few centimeters an hour. Even though the electrons make very slow progress along the wire, the circuit still starts working almost instantly, because the electrons are already there everywhere in the circuit, and they all start moving everywhere at the same time, like the carriages when the train leaves the station.